Jai Hind to all of you. I am Dr. Gaurav Saxena, Associate Professor in EC Department. So today I discuss the Unit 4 PUT questions which has been asked in 2026, and the code is BEC 201 and the course name is Fundamental of Electronics Engineering. So in 2026 these question has been asked. This is the converted the following terms. So this is a radix 10 and you convert into the binary number. So that means we have to convert this decimal number into the binary number. So we change the radix from 10 to 2. And second question, we find the radix of x. So that means in any of radix, the number 211 which has been represented in octal form, which one is 152. So we find the what is the value of radix x, and this is second question. And third question is subtract using 2s complement. So this is the first number and this is the second number which has been designed on binary number. So we subtract these two numbers by using the 1s complement method, and we subtract these two numbers 10 minus 57 which has been asked in the radix 10. So we 45 minus 57 having a radix 10. So by using the 1s complement and as well as the 9s complement and 10s complement methods. And another question which has been asked is describe the what is the universal gate, and describe the universal gate, and we realize the universal gate by using the NAND and NOR gates, or in this question we have to design NOT and or NOR XOR gate by using the NOR gates only. And fourth question is been asked is we have to design a XOR gate by using the 4 NAND gates only. So this is the fourth question, and this is a very important question which has been asked by using the K-map. We reduce this expression by using the pause method, and this is a 4 variable questions, and this is a 5 variable question, and this is a 5 variable question. So this is a min term. So we solve this question by using the SOP method, by using the K-map only, and we realize the function by using the NAND gates only. So first question. So what is the first question? The first question is this: 143.733. This is a number which represent in decimal form. So we convert into the binary form. So that means this is a radix based question. So radix interpolation question. That means the we have to change the radix 10 to radix 2. So that means we have to just convert this decimal number into the binary number. How we solve this? So first we taking in this term 143, and in which we have to change. This is a radix 2. So we divided this radix 2. So that means this one is 2 7 ja 14, 2 1 ja 2. So remainder is 1. 35 2 ja 70. So remainder 1. This one is 17. Remainder 1. 2 8 ja 16. Remainder 1. 2 4 ja 8. Remainder 0. 2 2 ja 4. Remainder 0. 2 1 ja 2. Remainder 0. And 2 0 1 and remainder 1. And then we have to be written like this from bottom to upper. So that means 143 is to be represented by 1 0 0 0 1 1 1 1. So that means this 143 is to be represented as 1 0 0 1 1 1 1. Then we calculate the how the decimal number we have to be calculate. So decimal number we have to be just written like 0.733, and in which radix you have to be changed. So we multiply this number. So we change in the radix 2. So that means you have to be multiply by this number to the radix 2. 2 3 is 6, 2 3 is 6, 2 7 is 14. So whatever this integer value is to be here, so we put this integer value here, and then the value is 0.466. Then we multiply is 2 6 is 12, 2 6 is 12 and 30, 2 4 is 8 and 9. So 0.912. So that means the integer value is 0, so we multiplied it, so the value is 1, then the value is 1, so we conclude this. So this number is to be represented by binary number. This 144.733 is to be represented as 10001111.1011. So very easy question which has been asked. So second question is find the base of 211x and which is equal to the 152 radix 8. So that means 211x, which one is equal to the 152 which are given in radix 8. So we find the value of x. So that means what is the value of radix x? So which is very easy. So we convert this into the decimal form in both of the sides. So that means this one is 2 into 8 raised power 0 plus 5 into 8 raised power 1 plus 1 into 8 raised power 2. So that means 8 raised power 0 1, this one is 2, and this one is 40, and this one is 64. So that means this is the value of 106 which is represented in decimal form, and we have to be calculated here. So what is the value of this? 1 into x raised power 0 plus 1 into x raised power 1 plus 2 into x raised power 2. So that means this quadratic equation is written as 2x square plus x plus 1, which one is equal to the 106 or radix 10, or this is also a radix 10. So that means this represents both are same radix. So we equate it. So that means 2x square plus x minus we have to be shifted here by minus 105, which one is equal to 0. So this is a quadratic equation. Then we find the what is the root. So x is equal to plus 7. We have to be put it. So which satisfied this equation. So that means x minus 7 is the root. So that means the radix of x is equal to 7. So the value of x is equal to 7. Next question is 1011 10111 radix 2. 10111 10111 radix 2 minus 110011 110011. We subtract these two numbers by using the 1s complement method. So by using 1s complement method, we subtract two numbers. So first of all, you have to check it how much digit is to be represented in that particular term. Suppose this is x, this is y. So how we calculate this? By using the 1s complement method. So what is the method is x is you have to be written as it is, and you have to be just taking a 1s complement of y, which is represented at y dash. So y dash we have to be calculated by using the 1s complement method. Then we add it. So what is the value is z. So z is the addition if carry occurs, then if carry occurs, then we add 1 into the summing term z. So this is the answer. So this is the answer. If we add x and y dash, if no carry occurs, so that means the value of z is with no carry occurs if we add it in the last term. So that means then we proceed a 1s complement of z. So that is what is the 1s complement of z? We have to be put it. This one is z double dash, and minus sign is to be put it. So that means if no carry occurs, that means the value of x is less than y. So that means if no carry occurs, what is the value of this? X is less than y. If carry occurs, so that means x is greater than y. So if no carry occurs, so that means this is a negative number. If carry occurs, this is a positive number. So that means when we proceed this, so 1, 2, 3, 4, 5, and in this x and y are not same, so we added a 0 here. So this is same. So that means what is the value of x? X is 0, 1, 0, 1, 0, 1, 0, 1, 1, 1. And what is y? Y is here. So y using the 1s complement method. So how we calculate the 1s complement of any number, any binary number? So just complement of each number. So they represent the 1s complement of these numbers. So what is 1? 1 complement 0, 0, 1, 1, 0, 0. So this represent the 1s complement of y, or we can say this is a y dash. So that means y dash is 1s complement method is 0, 0, 1, 1, 0, 0. Then we add it 1 plus 0, 1, 1 plus 0, 1, 1, 1, 0 added and 1 carry. So that means 101, 10, 101, 10, 1. So this is a number having no carry. So that means no carry, that means no carry occurs. So that means this represents a negative number. So we can say this is z. Z is equal to this. So if no carry occurs, so what is the answer? You have to be just given a 1s complement of that particular number, which one is z dash. So what is the value of 1s complement of this number is 1 ka 0, 0 ka 1, 1, 1, 0, 0. And negative signs we have to be put here. So this is the answer. So what is the value of this number? Which one is this? By using the 1s complement method, we easily calculate what is the value of this. Next question is subtract using 1s complement method. So another number is this one is 45, which represent in decimal form, and 57 also in represent in decimal form. So by using the 1s complement method, so you subtract these two numbers. So we easily calculate. So next question is 45, which are represent in decimal form, and we subtract this by using the 45 minus 57. So 45 minus 57, we have to subtract by using the 1s complement method as well as 10s complement methods. So how we calculate is by using the 10s complement method. So 10s complement, that means this is x, this is y. By using the 10s complement method, we subtract two number. How we calculate it? X and y. This is the, what is the 10s complement of y is y dash. So they represent, we added, so they give it the number of z. If carry occurs, so that means we discard this carry. If carry not occurs, that means the zero terms. So we further we calculate the 10s complement of this z number, which one is z dash, and negative sign we have to be introduced. So that means how we calculate it? So this is 45 and this is 57. So how we calculate the 10s complement of 57? So we further we have to be just minus 100 में से how much quantity we have to be left by this. So this is the 10s complement. So this is 43. So 43 is the 10s complement of 57. So that means this represent, this is x and this represent the y dash. Y dash, what is y dash? Y dash is the 10s complement of y. So that means this is 43. Then we added 538, 448. So no carry occurs. So you have to just see that no carry occurs. So that means this is z. If no carry occurs, so that means we further we have to be taking a 10s complement of this z. So what is the 10s complement of this z, which represent the 12, and minus sign we have to be introduced. So that means the value of this number is 12, minus 12. So that means 45 minus 57, which represent the minus 12. And another question which has been asked, what are the universal gate? And we realize the and not and or and XOR gate by using the NOR gate. So what are the universal gate? So universal gate are, so universal gates is represent a universal gate by using the NAND and NOR gates. NAND and NOR gates represent the universal gate. Why? Because by using these NAND and NOR gates, we implement all the basic gates, just like all the basic gates. So that means the NOT gate, OR gate, XOR gate, AND gate, XNOR gate. So that means by using these NAND and NOR gate, we implement all the basic gates. So we can say such gates NAND and NOR acts like a universal gate. So how we calculate how we design a basic gate by using the NAND gate. So first one is we have to convert NAND gate to the NOT gate. So that means this is NAND gate, and we just common the input term. So what is the value of this? A dot A. So that means A dot A is equal to A. And what is the value of this? A dot B ka whole square. So A dot A ka whole square, what is the value of this? A ka bar. So which represent the NOT gate. So by using the NAND gate, we have to just implement this NOT gate. So this represent a NOT gate by using the NAND gate. So that means the second term is how we calculate how we design a NAND gate acts like a AND gate. So that means this is the symbol of NAND gate, and this is the input A and B. So what is the output of the NAND gate is A dot B ka complement. Then which we have to just design a NAND gate as a NOT gate. So if we shorted these two inputs, so that means suppose this is X, or we can say this is X dot X bar. So that means what is the value of this is X dot X. We know that X dot X is equal to X ka complement. So X is A dot B. So A dot B complement and A dot B complement, which represent the A dot B, which gives the output of AND gate. So that means, and by using how we calculate how we design a and NAND gate acts like a OR gate. So that means this is A, this is A bar, this is B, this is B bar, and if we design it, so what is the value of this? A bar dot BR complement, suppose which is equal to A plus B by using the De Morgan's law, and which represent the OR gate. So suppose how we calculated A bar is equal to, suppose we have to suppose that A bar is equal to X and B bar is equal to Y. So that means this one is X dot Y ka whole bar by using the De Morgan's law, which represent the X bar plus Y bar. So what is X? X is A bar ka bar plus B bar. So that means which represent the A plus B. So we easily convert NAND gate acts like a NOT gate, OR gate, and AND gate. Thank you.